Today we are going to learn about system of equations using determinants. From the previous two sections, we have used two methods to solve a system of equations. Substitution/elimination that you learned back in Algebra 1 and 2, and the one that we learned last lesson, which it was row operations using augmented matrix. The third method that we're going to see today is determinants. Okay, so what is a determinant? If we have numbers, four real numbers A, B, C, D, okay, we know that the symbol D equals, and we have A, B, C, D like this, kind of like a matrix, okay? It's called a 2 by 2 determinant, okay? Its value is going to be the number AD minus BC, okay? This means that what you're going to do is you take A and D, we multiply it, and then minus, and then C and B, okay? So you have this equation, okay? It's a multiplication of numbers, and then you subtract the other two numbers, okay? So in the following example, you have -2, 3, 4, -1, and you want to find the determinant, okay? So first you want to find it via the algebraic solution, which is going to be pretty simple because you know that it's going to be -2, -1 minus 4 times 3, okay? So this is going to be equal to +2 minus 12, which is going to be equal to -10. And that's going to be your determinant. Now, if you want to do it via the calculator, okay, so what you're going to do here is obviously you're going to turn your calculator here. And to do this, what are you going to do? You go to matrix and vectors, you are going to select the determinant, then you go to menu here, okay, go to matrix and vector, then you create your matrix, okay? It's a 2 by 2, so you're fine with the one that they give you, and you put -2, 4, and then you have 3, -1, and then you hit enter, and you have that it's -10. So we have exactly the same situation, okay? So on your notes you are going to have this, which is the same, okay? So with this being said, why we care about determinants? Because determinants will take you to what we call the Kramer's rule, and the Kramer's rule will help you to solve systems of linear equations, okay? So in this case we have the system of linear equations ax plus by equals s, and then we have cx plus dy equals t, okay? By elimination, it would be a little bit kind of tedious, okay? So if I want to use Kramer's rule for this system of equations, what are you going to do? Well, what you're going to do is you're going to find the determinant, okay, of the x side, meaning you are going to replace the x coefficients by the constant coefficients, and you're going to leave these coefficients by itself. And then you are going to have the coefficients of the xy as the denominator, and you're going to find the determinants of each one of this, okay? So that's what you have for this equation, aka what we have is, let me write it here. You have, of course, you don't want the denominator to be 0, meaning this determinant cannot be 0. Are we okay with that? Let me use better notation, okay? So the notation, this is not very user-friendly. The user-friendly notation that we have is this one, okay? So as you can see, we have exactly the same system. I don't even know why we use the other one. It's not user-friendly, okay? So what you have here is you're going to find the determinant of this part of your system of equations. That's why you have A, B, C, D, okay? So you find that determinant, and then you are going to find the determinant where you are replacing the x column by the constant column, which is this, and that's why it's bolded. And then you are going to have the determinant where you are replacing the y column by the constant column, so you have this. The only condition that you need to meet is that the determinant of the original, this one, needs to be different than 0. Once you have that, all these numbers, that you have 3 numbers, what you're going to do is it's going to be the ratio between this guy divided by this one and this guy divided by this one, and that's going to be your x and that's going to be your y. Okay, so let's do it with an example over here. Okay, So what you have here is you have the situation, okay? So what you need to do from this one, I want to find basically what I call D. D is going to be 3, 5, negative 6, 4. Okay, so this determinant, I know that it's going to be 3 times 4 minus 5 times negative 6. Are we okay with that? So you have that this is going to be 12 plus 30, okay, and you have that this is going to be 42. Are we okay with that? After that, you need to find the dx. What is this so-called dx? We're going to replace the 3 and the 5 for what? 24 and 12. So you have 24, 12. This one, you keep it the same, okay? Then my determinant is going to be 24 times 4 minus 12 times negative 6. Are we okay with that? So you know that 24 times 4 is going to be what? It's going to be 96. And then negative 6 times 12, what's going to be negative 6 times 12? It's going to be 72, okay? Positive because it's negative and negative, so it's going to be positive. And then you have that 72 plus 96 is going to be what? 168. Are we okay with that? So that's going to be your dx. Now your dy, what you're going to do is the original, you keep it like 3, 5, and then you're going to replace negative 6 and 4 by what? 24 and 12. So you have this equation having what? 3 times 12 minus 5 times 24. So this is going to be equal to 36 minus, and what's going to be that? You know that that's minus 120. Okay, I wrote what that? Yes, no, kind of iffy, you tell me. Okay, and this is going to be equal to negative 84. Okay, so what are going to be your solutions? Well, your solution x is going to be equal to what? It's going to be equal to 168 divided by 42, and y is going to be equal to negative 84 divided by 42. With this being said, you can of course simplify those two solutions, okay? And you know that this is going to be 4 and this is going to be negative 2. Okay, and that's going to be your solution. Are we okay with that? So as you can see, we obviously can use the calculator. Okay, you can use the calculator to find all these determinants using this feature, okay, matrix vector and then determinant. But actually it's kind of like the same as tedious, okay? The only thing is you will have this directly, and this directly. You just need to remember that it's a ratio. Are we okay with that? So it's another option. Moving on, we are here just dealing with basic notation, okay? These are the entries. This is going to be the determinant, but honestly we're going to do it with the calculator, okay? So this is just an FYI. Okay, so let's move on to this one. Okay, so if we want to evaluate 3 by 3 determinants, okay, so if they are asking you for the determinant A equals this, find M 2, 1. Okay, so what are you going to do? The 2 is talking about the row, okay, and the 1 is talking about the column. Okay, so what you're going to do is you are going to find the determinant basically using the remainder numbers that you have. In this situation, M2, 1, it would be equal to negative 1, 6, 3, negative 9. This, as you can see, it would be negative 1 times negative 9 minus 6 times 3. This is going to be equal to positive 9 minus negative 18, and this is going to be equal to negative 9, and that would be your answer. Please note that this is M21, telling you that basically you are going to eliminate this row and this column. Okay, so the definition for an n by n determinant A, we're going to use what we call the cofactor of entry A, ij, denoted as this. Okay, and this is just notation, don't let it to intimidate you. Aij is going to be equal to this, where Mij is going to be the minor entry of this. As you can see, this is the M that we just compute. Okay, this negative or positive is going to be determined by basically the entries of the rows and the columns here. Okay, so I'm going to show you how it looks to do it by hand, okay, which is here. Okay, but if you do it with the calculator, it's super simple. Okay, so you can see how I'm doing it here by hand. Now this is going to be because it's 1 1 and so forth. Okay, so you can see it by hand, but you can always do it with the calculator. Okay, so with the calculator, what are you going to do? So you have this matrix. Okay, so you have a bunch of options. Okay, you are going to find the determinant. If you don't know where to find it, go to menu. Okay, matrix and vector, go to the determinant. Okay, over there it needs to be blinking there. Go to menu, again matrix, vector, create a matrix. Okay, create a matrix. Okay, after that your matrix is going to be 3 by 3. Okay, in this case, why 3 by 3? Because that's what you have, 3 rows and 3 columns. Okay, so you enter your numbers here. It's going to be 1 3 2. Okay, then this 2 1 1 7, and then you hit determinant, and then you have the -1. So you can see with the calculator, super easy. This is going to be equal to -1 and done. Okay, as you can see, it's exactly the same thing. So as you can see, the calculator can save you a lot of time. Okay, so over here, the Kramer's rule for 3 equations is going to be kind of like the same that we had before. What's the only difference? Here, instead of having only x and y, we have x, y, z. First, you're going to find the determinant of this situation, and then you're going to be replacing it as we were doing it before with x and y. Okay, so the dx is going to be when we replace the coefficients of the x with the linear coefficients and so forth. Okay, so I'm going to show you the example.